Okay, so my name is Choi. I am the Innovation Analyst from UK Power Networks, one of the members of the ENA. And thank you, Farina, for actually laying out a lot of the foundation and all the definitions of some of the terms that I'll go through to save me some work. And today I'm going to talk to you about what we think the value of data is to our business. So briefly, the agenda for today, do a little bit of overview of who UK Power Networks is, what are the data challenges and what are we doing about it, as well as what we can improve on in the next steps. We have questions and answers at the end. So, I mean, some of you are probably familiar with this. The UK network structure on top is National Grid with the transmission network, and then we operate everything under 122 kV down to 400 to 230 volt, which is the low voltage network that supplies electricity to your home. And UK Power Networks is one of the 6 distribution network operators in GB. As you can see, we operate in East England, most of London, Greater London, and the South East England patch. And although we're one of the 6 DNOs, we do supply more than a quarter of the customers. So 28% of the customers in the area is supplied by us. We also account for almost a third of the distributed generation connected to our patch. So what are some of the data challenges that we experience as a business? So I kind of classified into 3 main categories. So the first one is, we own a lot of asset data, we have a lot of operational data. What can we do with the existing data that we already have? How can we extract more from the existing assets in order to run our networks more efficiently and effectively and ultimately benefiting our customer? The second theme is low carbon transition. So we're experiencing huge uptake of electric vehicles, and before that the PV solar panels that people install on their rooftop, and we need to know where they are. So for example, where are the electric vehicles charging? How are they charging? And as a result, what's the load impact on our network? And the last theme, which we all heard about in the previous presentation, is the DSO transition. So currently we're operating a DNO model where we have one directional flow of electricity from the generator to transmission to distribution to your house. But now with all the uptick of electric vehicles, electricity flows both ways, and customers are more aware of energy. What can we do to kind of answer their needs and their new questions, and how do we create benefits for all the parties? So in that, we need to understand what are the data streams needed. How do we, how do they flow? What's the proper communication to, answer all these new changes? So I'm going to give you a few examples of some of the projects that we do in UK Power Networks. Most of them are innovation projects, and how these projects fit into the 3 areas I just talked about, and what are the benefits from, the value of using the correct data and realizing benefits. So this one is the real-time thermal rating model. So on the left-hand side, you can see that is a typical annual load profile of a transformer. It goes from January to December, and there's a pointer. Oh, there you go. That's easier. So it's not constant low. It's peaky in the winter times, and the line here is the thermal capacity of the transformer. So traditionally, we only rely on thermostatic ratings, and we do not take into account ambient temperature. We might have 2 ratings, or a summer rating and a winter rating. Sometimes we have emergency rating. But if you look at this graph, the rating actually varies with the ambient temperature of the transformer. So traditionally, we have 1 rating for summer, which assumes the ambient temperature at 35 degrees Celsius. And we all know that summer is not 35 degrees every day. I mean, I wish that was the case, but it's not. And again, for winter, we assume it's 5 degrees all the time. But on the cooler days, we can actually run our transformer harder and put more flow through it, so then we can maximize the utilization of our assets. So, well, that sounds very, it sounds like a no-brainer. Why don't we just do it? Well, when you manage like a huge network with hundred thousands of transformers, it's really hard to assess these manually. So what we need to do is scale this process to every transformer in the network, which is why we built a RTTR model. So this is an in-house tool that we built. It's very exciting for an old utility company. And what we do is we take the winding hotspot temperature limits from all the different transformers, the historical ambient temperature, with some site-specific data. We put it into a thermal model with some clever data science that outputs a more dynamic, realistic rating for the transformer that the planners can use to plan their work. And on the right, this is the screenshot of the interface for tool. It's still in development, but as you can see, it's very easy to use. There's not that many inputs that you need to put in. So for the planners who don't always have intense, modeling training, it's easy for them to use. And then from that, they can make more informed decisions on, how to operate our assets. So one of the big benefits of, rolling this out would be we can defer some of the unnecessary upgrades of the network because if we know we can actually push our transformer a bit harder, we don't have to put in new, upgrade our transformers as often. Another benefit would be in the case of one of the transformer in the substation failing, we can actually maybe push the remaining transformer harder for a short period of time, depending on the situation. And instead of do that instead of putting customer off supply. So that would be so ultimately basically allows us to operate beyond the fixed limits. So we mentioned a lot of DSO transitions, and one of our flagship projects is power potential. So this is the first whole system collaboration to improve voltage stability and therefore connecting more generation. So I mean, I'm sure a lot of you know that if you have a lot of generation connected, it increases the variation in the whole system load and therefore affecting the voltage stability. In this project, we are working with National Grid to test the potential impact of reactive power capability from the existing embedded generations on distribution level and how that can improve the system voltage stability. And we're testing it in our Southeast England patch because that's where most of the DERs are connected in our network. So the technical solutions that we're trialing in this project is the dynamic voltage control from DERs. So once they bid in, how do we automatically dispatch the DERs, and this could be both reactive and active power support, and how does UKPN in the middle facilitate this transaction. And from a commercial point of view, we are also trying to establish a new reactive market for the embedded DERs on the network. So all of this all of this work cannot be facilitated without a very comprehensive design of the architecture. So forget about the acronyms, but on one side you have the DER customers on the right, and on the left you have National Grid, the system operator, and in the middle is UK Power Networks facilitating the process and the communication of data. So the day ahead in this trial, DER would put in their volume and their price. So I want to bid in for this availability and utilization period, and then send it to us, and then we will run a flow model to assess if there's any constraint on the network with what they're bidding in, would there be any problems if we accept the tender, and then we then pass on this information to the National Grid, and then they run their assessment and then inform us well, I want A, I don't want B, and then we dispatch automatically from the DER side of the substation. So by working together, we enhance the visibility of the embedded generation for the system operator, and as a result, with all the voltage balancing, we expect to add other benefits created will allow us to add another 3.7 gigawatts of renewable generation to the Southeast patch by 2050. And again, this is another an example of how the whole system approach can benefit both our customers, create a new market for the customers, as well as how to manage our networks more effectively. Also, I have information of all the project managers from UK Power Network sites on here, and when I send out or someone sends out the deck, you can also contact them if you want really detailed information. This is just a more detailed version of the previous slide. As you can see, it's very complex. There's still a lot to be built, but that's the plan. And I guess the key message here is we can't work alone, and there's always improvement on every element of this. So one of the problems we experienced so far was the data quality. So you have these amazing tools, but then what's extracting the very foundation of this is not. Sometimes it gives you a lot of error that you can't move forward. So we're working on it. This is the most exciting part of the presentation. It's my favorite topic. So I'm just going to let you watch the video for a little bit. Oh, okay. So the last theme that I mentioned is about the low carbon transition. And obviously, electric vehicle is a very hot topic now. And as a company, we have electric vehicle strategy because we know this is the new load, and this is something that's going to affect us very differently from all the historical load. And the first pillar of our EV strategy is forecast. So using data to forecast where the EVs are, and as a result, we build the most granular EV forecast model. This really looks into the effects of geospatial variation, and this is important because we're not only interested in how many EVs are going to appear on the networks, but we're also very interested in where they're going to appear and how they're going to charge. So because a lot of these constraints are very localized, overall, like we can there's probably capacity on the networks to supply all the EVs for quite a while, but there might be patches on the networks where we need to reinforce or we need to do something about. But before we get there, we need to know where they are, so then we can inform our investment plans. So for this project, it's called Recharge the Future. It's another innovation project. We made use of a lot of external data sets. So we worked with Element Energy, who's the consultant who built this model for us. We looked at the current numbers of EVs, where they are, and how do socioeconomic factors affect the uptake of EV in those areas. We also looked at different charging patterns. So we worked with charge point operators or the service provider ZapMap, who they have all the locations of the charge points and a lot of information about how they're used. So we work with those parties to get a more comprehensive picture of the load impact of electric vehicles. We actually, as part of this project, published a charger use study. So that is looking into the social side of electric vehicle charging. And also we looked at the utilization of different charging infrastructures. So if you have access to slow public charging in your areas, would you charge that for most of your time, or would you actually top up at rapid charger? So all of that fed into the model, and currently we know there are about 60,000 electric vehicles in our licensee area, and we predict up to 4.1 million plug-in cars across the entire UKPN by 2030. So that's quite a significant increase. So I mentioned we use a lot of different data sets, and obviously the model is as accurate, as good as what the input data is. So this is a way to represent our data strategy in terms of EV forecast. So it's a data onion, and it's the shape of an onion. So in the core, it's the basic of our data set. So we have just the total number of EVs in the country. but then we take one layer out and see, well, I want to know where they are and who has access to that information. Can we get it? And then we go, a bit further and further to try to, go to more granular sets of data. And, some of them might be free, some of them might be easy to get, and some might, require a bit more effort. But at least we have visibility of that and know how much accuracy it gives us for a model, and is it worth pursuing, maybe just 1% more accurate, like, do I really care? And ultimately that, again, informs our model. So, when we know there's high uptake here, we can, focus in that area. So, yep. And so this is the second pillar of our EV strategy. So once we develop a model, develop a forecast model, how do we verify that our model is accurate, or how accurate it is? So we're investing £30 million on LV monitoring. So these are chosen strategically based on the low carbon technology uptake. And so we currently don't actually have very high low voltage, yeah. So currently we don't have a lot of monitoring on a low voltage network. So this is the 400 volts down to the supply service cable to your house. And that is because historically we never had the need to. In a DNO world, the power is very one directional. It's very predictable. It's just, there's so many substations, distribution substations, that it's just not worth monitoring all of them. But now, because of the uptake of LCTs and electric vehicles, we see the need to, target a few areas where we expect a high uptake. And that's important because, by knowing where these EVs are and confirming that they're there, it could inform, should we procure flexibility from these loads? Would there be enough volume to give us what we want? We're also doing a lot of EV projects to test the market on, for example, smart charging and profile connections. So if, when we know that here's the EV clusters, we can decide, okay, do we do a flexibility solution, or do we need to actually build, because flexibility won't solve the volume that we're seeing on the networks. So, and obviously, this piece of work, it's supporting both our EV strategy and the transition to DSO, because obviously, it's not just about EV when we have the monitoring of the local network. So, to conclude, we have identified a few key areas where we experience data challenges, or areas where we think, a good use of data could give us, more benefits. And we've had innovative solutions targeted in each of these areas. What I presented was only a tip of iceberg. We have a portfolio of like 60 projects, so that was only a few examples I want to share with you. Ultimately, we want to do all this work to unlock benefits for both the networks and the customers. We want to, listen to what they want, and do some innovation projects to maybe develop solutions away from just traditional reinforcement, which is very costly. And ultimately, we know we can't do this alone, so we collaborate across industry. So obviously, we're part of the Open Networks project. We work with National Grid from a whole system approach. We also work with a lot of suppliers for some of our smart charging trials. We work with the fleets, because when they electrify, they're going to come in, in mass. So we're part of a lot of the energy task force as well, to iron out how the data should flow and what should be made public. But that being said, we know that there's still a lot that we can improve on, and we will welcome your ideas if you have any new ideas. We work with academics a lot as well. So if you think you can help, you can submit your ideas on our website, or email us at the email address there, or just drop me a note. And our innovation team has like a team of 30 more people. We actually do a lot of innovation projects that addresses different issues. So thank you for listening to my presentation, and I can accept any questions.
Any questions? Yeah, we have a lot here.
Thank you for an nice talk. When I saw the title of your talk and seeing where you come from, I was just sure you would tell us about the value of smart metering data in your business. I don't know if you can comment on that. You say you had lost 60 projects, you say?
Yeah.
How many of those are trying to get the most value out of this smart metering data?
Yeah, so we don't roll out smart meters, so the suppliers roll out smart meters, but we do have a team. It's not within innovation, but we do have a team that look at the value of smart meter data. We don't have a high visibility of that currently because I think it's still very low penetration, but it's hard. We might actually get smart charging data before because it's already mandated by the secondary legislation that trusted parties such as the DNOs and the supplier.
So it's kind of the context that makes you don't have a clear view. It's just not there yet for you.
It's not there, and we're not. It's not our role to roll out smart meters. So, but
I'm not talking about the rollout. After when the data is flowing, I
Mm-hmm.
guess you have a high interest in.
Oh yeah, definitely. There's, I'm excited to play around with the data when data is available as well.
Well, it may sound a fairly naive question, but do you work with the other DNOs?
Yes. Yeah. Yeah.
I get the impression, since they're all doing their own thing, they realise the importance of being talented.
Yeah. So.
Use talking to each other.
Well, that's why we have the ENA. We actually meet quite often with all the other DNOs. We do have projects where we work on our own, but some of these projects are collaborative. So, or we learn from each other. So, in terms of the EV forecast, we actually made use of data sets from Electrification, which is run by Western Power. So they did the first the large-scale EV trials, and then from that we kind of get the data from them. And some of our trials we partner with, for example, SSE, because their southern patch is close to our patch, so then we can expand the areas. And we have a lot of projects that we
I have a question about condition monitoring. So you were saying that you were deploying metering so you could see what the load was of the assets. But I guess quite a lot of the assets that you have been around for quite a long time. And so what's on the sticker outside is not necessarily what that device is able to handle right now. Is there any kind of data solution to kind of infer what that device is able to handle now, or do you have to just do a 60 testing? Or is there any way to figure out how much overhead you actually have?
So at a distribution level, which we have very little visibility of, it is kind of like what you said. It's very manual. We usually it's a very reactive approach. When there's a fault or maybe someone complain about flickering, we go put some measuring device on and for a week and be like, okay, so this is overloading or underloading, and there's no problem. So currently, as business as usual way, that's the way we're doing, which is not efficient, as you can tell if all the EVs come on. So we have a strategy that's trying to roll out a new way of assessing all these issues at the distribution level, because there's a lot of them, and traditionally we're just not designed for that operations, but we're getting there.
In your EV predictions, your EV model is exogenous, right? But have you thought of the EV uptake responding to the grid expansion, in the sense that if you can't charge your vehicle at lots of charging stations, you're not going to buy one?
We're trying to avoid that scenario, because that's why we're doing all this work to make sure that we are geared up, because currently we have capacity, and we expect to have overall we have capacity for a very long time, but there might be some patches in the network where we think we might need reinforcement, but that's why we want to forecast, and we're actually constantly improving our forecast. This is an update to a model we had 2-3 years ago, and I know it might sound like a no-brainer, but traditionally we don't do that because they don't come nearly as fast, and we usually have a few years to plan ahead, whereas now we need to be more proactive. So this is a big step change for us.
In other words, in the Northeast, we have a lot of solar that gets on the system, and then distribution companies require, I don't know how often, every month to update what is the capacity at each substation that you can actually integrate into your grid without upgrading it. And it's become a very big issue. But you just mentioned that you have enough capacity. Is that just for electric vehicles, or if you have somebody who wants to bring some other VR, are there requirements for upgrades, and how much do they cost? And comment on that some more?
So it depends on case by case. So when I mentioned there's probably enough capacity for the near future for electric vehicles, I mean, as the whole networks, if you add up all the capacity, there probably is enough, but there will be patches, locational constraints. That's the point. So we need to know where more than just the overall load.
So do you charge as one entity comes, or you do this on every year? You say you want to have a queue of VRs that want to get on your grid. Do you charge everybody as they come, or they share that cost?
So in general, it's first come, first serve. I'm not most familiar with our rules, but it's usually first come, first serve, and then there's some second comer rules that depends on the connection agreement. But so far, currently, it's usually first come, first serve.
The first guy pays the most, right?
Well, but we have a lot of we actually have a lot of smart solutions that is trying to lower that. But that's the rule. Yeah.
So in future, when there will be a large number of electric vehicles at the level of substations, how do you see management of charging of multiple cars in the same district? Because they will all arrive from work, plug their cars, expecting to charge them by the morning, because this is kind of most comfortable scenario for charging. And substations just goes like this. It should be scheduled with some kind of aggregator. Are you prepared to take this function, or you will be doing it as a paid service for some aggregator company?
So we're doing a smart charging trials actually, and our position is we facilitate third parties to do all the aggregation. So we just incentivize, but by no means are we going to stop people from charging just because we see.
So it will be shuffled around the night somehow.
Yeah, so we'll know this is our need, and then we work with third parties to make sure they give the proper propositions for the customers. So
sooner or later, when there will be a large number of electric vehicles, people will start paying for them, right? Right now they are incentivized to buy electric cars, and please charge wherever you like, free, enjoy it. But when there will be many of them, you will start punishing them, right?
No, I mean, we're not in a position to tell you whether you buy EV, but we are, prepared for when they do come. And we agree that there will be a point where we have to upgrade our networks, but we want to maximize the existing capacity first, and also, invest where is actually needed, not just the whole network. So,
Okay, so should we thank Carol again?
Thank you.